To my third Ti-Nspire walkthrough. Without any hesitation, let's get started. Um, the agenda for today is I'm going to show how to identify the local extrema or local extremes of a function. These are usually called like relative maximums or minimums. So first of all, let me answer the question: what is a local extreme? What does relative mean? Um, so relative means that it like the maximum or minimum that you're finding in a function. It's not it's not like by its like it's within a certain interval of points in a function, and I'll show this a little bit later. You can find a point in that small interval, which is the highest among the points or the lowest among the points if it's the minimum. Local and relative mean that the max or minimum you're finding um, are surrounded by other points, and that they are um, like in the neighborhood of the rest of the function, and like in certain segments of the function. So and or certain curves. I mean. So yeah, without further ado, let's keep going. So yeah, I'll show you how we find relative maxes and minimums. There are many ways, but I will show you how to find them first using the um, uh, first using graphing tools, using Ti-Nspire, and then the first derivative test. And I have an example MCQ problem. Um, Before I run through this, I would just strongly recommend pausing this video right now, and then trying this problem for yourself. Um, and then yeah, I'm gonna start, and yeah. Okay, so the example MCQ problem is say you have the function f of x equals 2x cubed plus 6x squared minus 5. What is the x coordinate of the relative minimum? And we have a couple options here. Well, first, let's try graphing this. And yeah, so let's go to our handy dandy Ti-Nspire. All right, so we have our graph here, and our function is 2x plus 3 minus 2x to the power of 3. Excuse me. All right, just going to copy this in here. And so yeah, this is our function. This is what it looks like on the calculator. And if we go back to our options, we have there is no relative minimum in the graph. Well, just by looking at this, we see that there is a relative maximum and a relative minimum right here. And they're relative because, well, there could be like, I mean, there aren't, because I know this graph, like what's down here and what's up here to the right, and um, there aren't. But if you wanted to, I mean, just by looking at these two right here, you know that there are relative maximum and minima. Um, so we know that our first option, that it can't be A, because there are relative extrema in this graph. Um, and if we look at our second option, minus infinity, well, first off, an x value can't be minus infinity. This is a limit. Secondly, relative means that it's not. It, Technically speaking, it's you're looking at a certain point, like within a graph, not an extreme, or another term that's used is global. If you're finding the maximum or minimum, like absolute minimum, absolute maximum, these are terms that are saved or reserved for the absolute maximum or minimum in a graph. Um, so it can't be B. Now C is potential, and then there's also D, which is 0. But to find the the minimum or maximum, what you want to do is you can either press menu and then go to analyze graph, and then click 2, which gets you your minimum, or 3, which gets you your maximum. I'm going to show you the maximum first, and you have a lower bound, so we start here, and your upper bound is here. And the graph immediately points out that you have a relative maximum at minus 2, comma 3. So x value equals minus 2, y value equals to 3. Now, if you wanted to do the minimum, choose the lower bound and go to the higher bound. X value equals 0 and y value equal to -5. So the relative minimum is where the y is the lowest or the smallest, and it is this one right here when x equals 0 and y equals -5. Don't confuse the two. I guess it could be easy just with a lot of calculator operations to mix them up, but maximum is, well, max and the most, and minimum is the smallest or the tiniest. So x equal to -2. Well, we know that I can't. This is the max. This is the relative max. And if we go to the next, yep, I can't see it being C, so it must be D. And yeah, so that wraps up the graphing part of this. What about the first derivative test? So we can use our calculator again. But if we go here, and I still have the function here. Okay, we can first store this as, actually, if you put it into the graph, it's already stored as a f1 of x as your first function there. So what we can do now is we can use the derivative. If you press this book here, you'll get this as one of your options to enter. We can put an f1 x. Now we know a derivative is the slope of the tangent line to the function. The slope flattens out here, and it flattens out here as well. And I'll show this in right here at our next step. So if you do this, you're getting the derivative of the function when it's equal to 0. And you can also type in solve here. But you want to solve for something. The solve function, it needs to take in some expression, like a derivative of a function when it's equal to 0. And it needs to spit out some answers. So I'm going to solve it for x because that's what we're trying to look for. Don't care too much about this caution symbol. This is something else, and you don't have to worry about it. All right, so here it says the derivative of the function equals 0 when x equals -2 or x equals 0. Now we can figure out whether each is relative max, relative min, just by plugging each point in to f1. So I'm going to put -2, and I get 3. Put in 0, I get -5. And as we all know, -5 is less than 3, so 0, x equals 0, must be our relative min x coordinate. So if we go back to our agenda, yeah. Oh, and try doing this for yourself, and you can do out the first derivative test where you try to get the signs and find each x value for when the derivative equals 0. And yeah, I'm running through this a little bit quickly, so pause if I'm going too fast, and try to find these for yourself. You can also write the signs here. This is really helpful because if you go from plus to minus, that means and if you follow my cursor, your graph is going up, and then flattens and then goes down, your f of x, which is positive and then negative. But if it goes from negative to positive, then that means you have a relative min. And so these are the signs. And we know that a min is when it goes from negative to positive. Relative max is when it goes from positive to negative. And so it has to be D, outlined by this golden circle. Anyways, here are some additional problems, just in case you want some more practice. And I got the answers below, but don't try to look at them while you're doing the problems. And yeah, I ran through this a little bit quickly, so feel free to contact me if I went too fast. Thank you for watching. If you have any questions or comments, feel free to email me. And yeah, thank you, and have a wonderful, wonderful day.